Hello, everyone. So we have 6.5, the Pythagorean Identity, Part 1. So let's start this off. And the first thing they want you to do is basically operate with this circle that they give you. And they say its center starts at 0, comma 0 with a radius of 1 unit. What they want you to do is they want to try to find the coordinate, all right, or the exact coordinate, rather, of P. Okay, and that's if it starts at 1 comma 0 but then is rotated counterclockwise of pi third radians. So go ahead and try to find the exact. Last lesson we did the approximation. They want exact. So how do we do that? So I want to go ahead and give you a hint. Two of them, in fact. And my first hint is, well, what's pi third in degrees? And then my next hint is involving special right triangles, SRTs. All right. So could you find a way to draw a special right triangle inside that circle? And then what could you use math wise, something you learned in geometry, to figure out how to represent your exact coordinate of P? So go ahead, spend the next couple minutes torturing yourselves. Try to figure out how you could exactly represent your coordinate for P. So, what is pi thirds in degrees? And could you draw a special right triangle involving P? Uh, and notice that your radius is 1. That's something else that I could probably go ahead and mention, right? So, your radius is 1. So, see if you can draw a special right triangle. And if you can find your degree, that's probably a hint on what kind of special right triangle you're talking about. And then what did you learn back in geometry that could be used right now to give you the exact coordinate of P? So go ahead and pause and work together with your group. So pause and try to figure it out. Give yourself about 5 minutes. All right, so hopefully you guys gave yourself about 5 minutes to try to struggle with this. But let's go ahead and start going into this. First things first, what is pi third? If you remember the lesson from previous, we understand that pi, and even in geometry you learn this, pi is 180 degrees. So what is 180 divided by 3? And you should get 60 degrees. That means your theta here is also 60 degrees, not just pi third, but 60 degrees. Now, what kind of special right triangle has a 60-degree angle? And hopefully you've realized that the next part of my hint was actually drawing a special right triangle inside that circle. So, got the red there. And let's get the weight a little bit higher up. Let's do 1. There we go. Nice. Very nice. Okay, and let's get the pen back in gear here. All right, so hopefully you see the special right triangle now. And what did we learn? We have our reference angle, right? We're a reference angle of 60 degrees. Now, what is our x value? Okay, so our x value, let's use a different color. Let's use blue. Our x value is this side of the right triangle. Now, what side is that? And hopefully you realize that is the adjacent side, right? And your hypotenuse is, of course, the radius. It's the longest piece of the triangle. So who uses, and dividing by 1, I mean, who cares? I mean, what's 5 divided by 1? What's pi third divided by 1? You know what I mean? So using the hypotenuse in this situation is going to be kind of nice. All right. So your adjacent, right? And your hypotenuse. What could we represent using trig to represent adjacent and the hypotenuse? And hopefully you're already like, wait, that's just cosine. And it's like, yeah, cosine. Now what of cosine? Cosine of what? What was our reference angle? And it was pi over 3. So that would represent the distance from here to here. Okay, the distance of your x. Basically, it's telling you, math-wise, how far over do you go on your x? That's basically what cosine of pi 30 over 3 means. All right, and let's figure out now our y value. So let's use green. Okay, our y value is this distance here. And what side of the triangle is that in reference to our 60-degree angle? And hopefully you said, oh, that's our opposite side. All right. And again, your hypotenuse is 1. So we could always use that to divide by, um, which is nice because anything divided by 1 is just that anything, right? So who uses the opposite over the hypotenuse to figure out your length in y? And hopefully you've said, oh, that's sine. So sine of what? Well, sine of your reference angle, which was, again, pi over 3. And that part, sine of pi over 3, is just basically saying, well, how far up do you go on your y value? You put those two together, you get p, the location on that circle. And that's exact. So notice how trig, special right triangles, and even converting from radians to degrees kind of helps out with this whole story of this situation. All right, so let's move on to, again, more trig. So cosine and sine is the emphasis here because those are the two that really help out with your coordinate systems. All right, so the question here is, what are the exact coordinates of point Q if it's rotated 2 pi third radians counterclockwise from the point 1 comma 0? So you're still, let me get back to my traditional red here. You're still starting here, but then you're rotating all the way over, okay, 2 pi to the, or 2 pi thirds, all right? So what would be the location for Q if you do that? And they basically are saying for the exact coordinates, okay? So you're probably going to use trig again to do that. So go ahead and try to figure that out. They do give you a interesting hint here of the coordinate P from last time. So this is the previous uh, from the previous activity of 5.1 from just a couple minutes ago. All right. So hint, hint, use that. Otherwise, you're going to be doing a lot more math than you need to. And this should help out big time with what you probably need for your response. All right, so they're asking for Q. Go ahead and work together. Make sure you pause it. Pause this video. Do, 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 do. If you hear this sound, you didn't pause. Okay, so now that you have spent hopefully at least 5 to 10 minutes working on this, you should realize, well, P, we already know the coordinate for P. We know it's cosine, right, of pi thirds. And this is again for P, not for Q, comma, sine of pi thirds like this, right? So what would Q have to be? All right, now do you remember that? Let me go ahead and draw the triangles. Hopefully you all did that or try to. If you did the whole triangle business like last time, right, that was something like that. Do, 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 do. Okay, there we go. There we go, Governor. And let's see. Here we go. Drawing. Okay. So hopefully you realize that we're still talking about the right triangles. All right. And if you notice, let's get another shape here. Let's get another line going. You'll realize you also have another right triangle right there for Q this time. Whoa. There we go. Okay. There we go. So what can your coordinate be for Q? Yesterday's lesson will definitely help out with this, all right? So your previous lesson does go over this. So what do you think? All right, so I'm kind of giving you some time. Hopefully you said something like this. And apologies, my handwriting on this touchpad has degraded since I've last used it. So it's going to be pretty sloppy. There we go. So hopefully you see now the connection between P and Q, because even if you just look at it with your geometry eyes, P and Q is just a reflection of one another across the y-axis. So that's why your x value just negates. It's basically just a reflection. And we experienced that in previous lessons as well. So it's good to see that come back into play, even though we're talking about exact coordinates this time. Now, is there another way you could write your equation? Or, I'm sorry, not your equation, your coordinate for Q? Is there an equivalent way of writing what we just got for Q? So I want you guys to think about it for a bit and see if there's another way of writing the same exact coordinate um, that would work. Okay, so hopefully you did this, and let me use a different color now that I think about it. Let's use green. Your reference angle would still be over here if you were to use that right triangle, right? You have your opposite, which is very much your y, right? You have your adjacent, which still is your x. So to get and your hypotenuse, of course, is your radius. That's an r, by the way. Sorry about that. A little sloppy. All right, so does everybody agree you're still using cosine? But if you were using that triangle is seriously based on 2 pi over 3. So cosine of 2 pi over 3, right, would give you from here to here going this way. Does that make sense for your x value? But what about your y? So let's try to do that. Your y is still going to be your opposite, right? Your opposite side over your hypotenuse. Opposite over hypotenuse is sine. And again, your reference angle is still going to be the 2 pi over the 3. Okay, so notice how those two coordinates are still going to be the same thing. Even if you were to plug them in a calculator, you would get the same thing. So negative cosine of pi third is going to be the same as cosine 2 pi third. So those will be two different answers, but it's for the same coordinate, the coordinate of Q. All right, so let's go ahead and move on to a new identity. So in order to do this, I'm going to need to explain what the Pythagorean identity is. So Let's see if we go down further. I just want to look ahead. Do we explicitly tell you? I think it's later on. Okay, so a new identity. So let me write this up here. Okay, let me get my classic red. Sorry, I'm taking forever. All right, so the Pythagorean identity. Um, we've all seen x squared plus y squared equals r squared with circles, right? And we've even seen a squared plus b squared equals c squared, right? Now, when you combine those two and you start applying trig to it, it gets a little bit more interesting because now we have all those little triangles, those special right triangles existing in that circle. So when we start applying trig, we notice that cosine represented the adjacent side over the hypotenuse. So cosine is the x value. So instead of x squared, it's going to be cosine squared of whatever your reference angle is, which we'll denote as theta, and your y value, right, which is squared, but we noticed y was your opposite over hypotenuse, which was your sine. So instead of y squared, it's sine squared of whatever your reference angle is, okay, equals your radius squared. Well, your radius in your previous examples was just 1, and 1 times 1, or 1 squared, is just 1. So this is your Pythagorean uh, identity, okay? So let's see. Let's look at a new identity. So using what I just gave you, is the point negative 0.5 comma sine of 4 pi over 3 on the unit circle. So I want you to use this Pythagorean identity and see if you get a true statement for that coordinate. So you're literally going to set it up like this. You're going to have cosine squared of, oh, nope, they already gave us that. Hold on. I'm getting a little too excited here. There we go. So, come on, where's my pen? There we go. All right, so use this one. X squared plus y squared equals 1. So test this coordinate, okay? So x was negative 0.5, and you're squaring it, plus y squared, which is the sine part, right? They actually give you sine of 4 pi over 3. So we're using x squared here because they actually gave us a number. But because for y, they gave us sine of, what was it, 4 pi over 3. Okay, we're going to actually have to type in or plug in sine. And when we square sine, it's like this, sine squared of the 4 pi over 3. And does that equal 1? Now, if it does, yes, that coordinate will be on the unit circle. Okay, so go ahead and test that. You may use a calculator. I do not see any harm in trying that, um, especially for the 4 pi over 3 squared. And actually see what you get when you do that. All right, see if you do 4 pi. So do that divided by 3, press sine, square it, and then add it to the negative zero point 0.5 squared. See if that gives you 1. All right, and that's going to take some work on the calculator, so you can totally use a calculator. Do the same thing with number 2. So this one is definitely for you. I highly recommend trying to figure these three out on your own or with your group. And number 3 is a really good one. Suppose that sine of theta, so your y value is negative uh, half, and that theta is in quadrant 4. So they're kind of telling you like it's got to be over here somewhere in quadrant 4. What is the exact value of cosine theta? Ooh, that's a good one. All right, and half is like literally halfway, right? Somewhere around there. So try to figure out what that would be. Okay. And again, you can use the x squared plus y squared equals 1 conversation piece. That would probably help out. All right, your cool down is very much of what we just did. You want to write the exact coordinates of P, and you probably want to be able to use a right triangle. So you want to be able to draw a right triangle, use that. And then they say in terms of sine and cosine. So you're going to have cosine of something, right? Comma sine of something, right? So now the question is where is or what is your radians for that uh, position of P? Which I don't think they explicitly say it, do they? No, they don't. In fact, I just gave it away on accident. So they just said theta, right? They didn't specify anything. So there you go. I accidentally did that one for you. But that's the general idea. Cosine is x, sine is y. And the reason we're using cosine and sine is because we have special right triangles in existing inside this unit circle. Now, if they tell us that theta equals this, what are the coordinates for P? So this is where you're doing the whole x squared plus y squared equals 1. What is cosine? Is cosine x or is cosine y? And that'll tell you exactly where to plug that in for solving for y. Okay, once you have y, give me that coordinate. Okay, and that should help you out. Now, just to let you know, P is in the fourth quadrant. So is your x value going to be positive or negative? Is your y value going to be positive or negative? So don't forget about that. You're still talking about a location. So go ahead and try to figure that out and definitely double check each other. All right. Okay. So again, we're talking about special right triangles, right? That's special right triangle that exists inside circles, and they help you find the location or the exact coordinates of a point that exists on a circle. All right, so we know that the Pythagorean theorem is this, right, in this situation, because your radius is 1, right? So unit of 1. And then we applied that to trig later, right? So we did, here's your x comma y. We're using cosine and sine because, well, we're talking about special right triangles, and that kind of helps us figure out our length in x and our length in y. So our Pythagorean theorem basically gives us this idea, which is basically leading into what we refer to on our unit circle as our Pythagorean identity. So when you see something like this, okay, we're talking about a certain coordinate of a point that went through some kind of rotation, theta, which is like a degree, okay, along the unit circle. And that kind of helps us figure out where they are exactly. So go ahead and work on classwork together. I like number 1 right here. It's very much based upon what we already did this, right? Didn't we deal with pi third already? So this is nice. So go ahead and go through the classwork, and if you guys have questions, let me know, and I'll see you when I see you. All right, thank you guys. Have a beautiful day and a wonderful weekend. Whoa, zoomed out way too fast. Whoa, okay, nice. I feel like Keanu Reeves. Whoa.